Hi friends, this is Rashekar, a GET faculty for electrical machines. Today in this video, we are going to discuss about open delta configuration. What is open delta first of all? In generally, we saw already the three-phase transformers can be made by three single-phase transformers connected together. This is called three-phase transformer bank. This is called three-phase transformer bank. In this three-phase transformer bank, if any single phase gets opened, then that configuration is called any single phase gets opened, then that configuration is called open delta configuration. If any single phase opened, that configuration is called open delta configuration. Open delta configuration. This is called open delta configuration. Out of three phases, if any single phase damaged or removed or failure or faulted, whatever it may be, if any single phase damaged, then remaining two phases will operate as a open delta which serve the three-phase load, which gives the supply to the three-phase load. This is called open delta configuration. Let's see, generally this is delta. In delta, line voltage is equals to phase voltage, and line current is equals to root 3 times of phase current. We know this. But in open delta, line voltage is equals to phase voltage and line current is equals to phase current. Both are same here. Line current is equals to phase current. Line voltage is equals to phase voltage. This is delta and open delta. For example, what is the kVA rating of delta? kVA rating of delta. In generally, kVA rating is nothing but root 3 VL IL. And here also, the kVA rating of open delta. kVA rating of open delta also is equals to root 3 times of VLIL is a general thing. Root 3 times of VLIL. But let's calculate. For example, the kVA rating of delta is equals to root 3 times of VL. VL is nothing but V phase. And IL is nothing but root 3 times of I phase. And here the kVA rating of open delta. kVA rating of open delta is equals to root 3 times of VL is equals to V phase and IL is equals to I phase. This is a kVA rating of delta and open delta. Okay. Let's see here the kVA rating of delta is equals to 3 times of Vp and Ip. But here the kVA rating of open delta is equals to only root 3 times of V phase I phase. Nothing but in generally in normal condition or in delta condition, this transformer will share the load of 3 into V phase I phase. But when out of 3 phases any one phase damaged, then the open delta configuration supplies the load of root 3 times of V phase I phase only. Root 3 times of V phase I phase only. This is very important. Let's see here. For example, each transformer capacity V phase I phase, each single phase transformer capacity V phase I phase, then the load capacity is 3 times of V phase I phase. But here, if the each transformer capacity each transformer capacity V phase I phase, but the load kVA is only root 3 times of V phase I phase. This is not 2 times of V phase I phase. This is only root 3 times of V phase I phase. Remember this. And next one, see here. Next one, see here. Generally here, for example, each transformer 10 kVA. I have a 3 transformers, 10 kVA, 10 kVA, and 10 kVA. Then the load shared by this closed delta is 30 kVA. It shares the load of 3 times of each one. 3 times of 10, 30 kVA. But for example here, each transformer 10 kVA, but the load shared by this open delta is not 20 kVA. This is root 3 times of 10 kVA. Nothing but 17.32 kVA only. 17.32 kVA only. Remember this. Are you okay? Nothing but here the utilization factor is 100%. What is that? Here utilization factor is equals to total load divided by number of transformers, or total load divided by the total capacity. Total capacity how much? 3 times 3 into V phase I phase, nothing but 1. So the utilization factor is 100% in delta connection. But here the utilization factor is equals to load kVA. Load kVA is root 3 times of V phase I phase. What is the total kVA here? Here 2 transformers with V phase I phase. So 2 times of V phase I phase, these 2 gets cancelled. So the answer is root 3 by 2, nothing but 86.6% only. 86.6% only. The utilization factor of open delta is only 86.6%. The kVA rating of open delta is only root 3 times of V phase I phase. kVA rating of open delta root 3 times of V phase I phase, and utilization factor is 86.6%. Here the utilization factor is 100% because load kVA 3 times of V phase I phase. Actually we have the capacity of 3 times of V phase I phase. Here each transformer loaded at what is the load on each transformer? The load on each transformer, if you want to calculate the total load by number of transformers, each transformer loaded it. For that, total load by number of transformers 3. So the each transformer loaded at V phase I phase, and each transformer capacity is also V phase I phase. Therefore, each transformer loaded at 100%. Each transformer loaded at 100%. 100% load is there. When comes to here, each transformer loaded at total kVA. The load kVA is root 3 times of V phase I phase, and number of transformers are only 2. We have only 2 transformers which sharing the root 3 times of V phase I phase. So root 3 by 2, nothing but 86.6% of load. Each transformer loaded at 86.6% of load. Here each transformer loaded at 100% load. This is operating at 100% load, but this is operating at 86.6% of load. That's why the load kVA is only root 3 times. If this is also loaded at 100%, then load kVA is 2 into V phase I phase. But here two transformers are not fully loaded. The two transformers are loaded up to only 86.6%. That's why the load kVA is only 86.6 plus 86.6. How much? 173.2. 173.2, nothing but root 3. This is the open delta configuration. So here you have to remember the kVA rating of delta is 3 times of V phase I phase. kVA rating of open delta is root 3 times of V phase I phase. And here utilization factor of delta is 100% or 1, and each transformer loaded at 100%. Utilization factor is only 86.6% and each transformer loaded at 86.6%. Are you okay? Now let's see here. Let's see here. Some small concept is there. We saw the utilization factor. Up to utilization factor. Next one. Let's see here. What is the load shared by open delta? The load kVA of open delta with respect to the load kVA of delta. Load kVA of open delta with respect to load kVA of delta. Tell me, sir, the load kVA of open delta is how much? Root 3 times of V phase I phase. And load kVA of delta is how much? The kVA of delta is 3 times of V phase I phase. So the answer is 1 by root 3. Nothing but the kVA rating of open delta is equals to 1 by root 3 times of kVA rating of delta. The kVA rating of open delta is equals to 1 by root 3 times of kVA rating of delta. Nothing but 57.1 by root 3, nothing but 57.7% of the kVA rating of delta. The load shared by the open delta transformer. Open delta is only 57.7% of kVA of delta. This is important. So what I am saying here, once see here, for example, on delta, I can load up to 100 kVA. Then in open delta, up to what percentage, up to what kVA you can load? So in delta, if the load kVA is 100 kVA, in open delta, the load kVA is 1 by root 3 times of 100. 1 by root 3 times of 100 or 57.7% of 100. 57.7% of 100, nothing but 57.7 kVA only. On closed delta, if you apply 100 kVA, then in open delta, you can apply only 57.7 kVA. For example, in closed delta, the load kVA is 10 kVA. Then in open delta, 1 by root 3 times of 10. 1 by root 3 times of 10 is nothing but 5.77 kVA. For example, in closed delta, you can apply the load up to 200 kVA. Then what is the load in open delta? That is 1 by root 3 times of 200, nothing but 1 by root 3 times of 200, nothing but mostly 115.5 kVA. 115.5 kVA. For example, in closed delta, you can load up to 173.2 kVA. Then what is the load kVA in open delta? That is 1 by root 3 times of 173.2, that is nothing but 100 kVA only. That is nothing but 100 kVA only. This is the load shared by the open delta corresponding to closed delta. Load shared by the open delta corresponding to closed delta. Right? Now the reverse. Reverse. The load shared by the delta is equals to just root 3 comes here. Load shared by the delta is equals to root 3 times of the load shared by the open delta. Root 3 times of the load shared by the open delta. Load shared by the open delta. KVA rating of delta is equals to root 3 times of open delta. KVA rating of open delta is equals to 1 by root 3 times. Here 1 by root 3 nothing but 57.7. Root 3 nothing but 173.2% of 173.2% of KVA rating of open delta. KVA rating of open delta. 173.2% of KVA rating of open delta. This is nothing but if the load shared by the open delta is 57.7 kVA, then what is the load shared by the closed delta? The load shared by the closed delta is equals to root 3 times of 57.7. Root 3 times of 57.7 is equals to 100. The load shared by the open delta is 5.777. Then what is the load on delta configuration? That is root 3 times of 5.77, which is equals to 10 kVA. The load shared is 115.5. Then the load shared on delta is equals to 115.5 multiply root 3, that is 200 kVA. The load shared on open delta is 100. Then what is the load shared on closed delta? That is root 3 times of 100. Root 3 times of 100, that is 173.2 kVA. Vice versa. This is the delta and open delta configurations, very important. Is it okay? Now, very small question. Let's see here. For example, here we have three transformers. For example, each 100 kVA. Here we have three transformers, each 100 kVA. This is 100 kVA, and this is 100 kVA, and this is 100 kVA. Then what is the load on this delta? The load on this delta is, we can apply up to 300 kVA, no problem. We can apply up to 300 kVA. For example, say here we have only two transformers, that is 100 kVA and 100 kVA, which are operating under open delta configuration, because one of the transformer open circuited. Then here, how much load we can apply on open delta? I said you root 3 times of kVA or 1 by root 3 times of delta. Nothing but simply root 3 times of 100 or 1 by root 3 times of closed delta. 1 by root 3 times of closed delta. This value 173.2 kVA will comes. Right. This is perfectly fully loaded condition. If 330 kVA applied here, then this is overloaded by 10%. And this 300 is shared by each 100. This 330 shared by each 110. Nothing but each transformer also overloaded by 10% perfectly. So don't apply 330 kVA. Just apply 300 kVA, then it share each 100 kVA, then there is no overload. And here also, if you apply 173.2 kVA, no problem at all. But if you applied 193%, 193 kVA, if you applied 193 kVA, then the system is overloaded. As well as each transformer also overloaded. As well as, now my question is, actually in delta we can apply 300 kVA. In open delta, we should not apply 300 kVA. For example, if I applied 300 kVA load on open delta, what happened? I applied 300 kVA load on open delta by mistake. I don't know, is the third one is open circuited or normal condition? I forgot. And I applied 300 kVA to the open delta as usually like a closed delta. Then what happened? What happens are overloaded automatically. How much percentage overloaded? How much percentage overloaded? How much percentage overloaded? Actually, if it is 173.2 kVA, this is 100% satisfying operation. But I applied 300 kVA, then what is the percentage of load? If it is 173.2 kVA, no problem, 100% perfect. But I applied 300 kVA, then what is the overload? So calculate it. 300 multiplied with 100 by 173.2. 173.2 can be written as 100 into root 3. 100 gets cancelled. 300 by root 3, nothing but 173.2%. If the same kV applied on open delta, the transformer loaded at 173%, nothing but overloaded by 73.2%. Overloaded by 73.2%, then machine damages actually. What is answer? Overloaded by 73.2%. Sir, actually, if 173.2 kV applied to a open delta, then each transformer share the load of 86.6 kVA. Each transformer share the load of 86.6 kVA. 86.6, 173.2. For example, I applied 300 kVA load on this open delta. Then each transformer share the load of 150 kVA. Each transformer share the load of 150 kVA. Nothing but overloaded. How much overloaded? How much overloaded? For this, calculate again. For 86.6%, for 86.6 kVA, this is 100% loaded, no problem at all. But when the 300 kVA applied, each transformer take the load of 150 kVA, then what is the percentage of overload? Tell me, calculate it. 150 multiplied with 100 upon 86.6. 86.6 can be written as root 3 by 2 into 100. Root 3 by 2 into 100. Then 100 gets cancelled. 100 gets cancelled. Then what is the answer? 300 by root 3. 300 by root 3. 300 by root 3. Nothing but this is also operating at each transformer operating at 173.2% of load. Nothing but each transformer overloaded by 73.2%. Each transformer overloaded by 73.2%. So, what is the question here? If the kVA and delta applied on the kVA, if the kVA and delta applied on open delta system, then the system overloaded by 73.2%, And each transformer also overloaded by 73.2%. This is the concept they may ask you question in your competitive exams. This is one concept. Then finally, in open delta, we have a two transformers. In open delta, we have a two transformers. Here, one transformer operates at 30 degrees lagging load and other transformer operates at 30 degrees leading load. One transformer operates at 30 degrees lagging load and other transformer operates at 30 degrees leading load. Nothing but the power in this one is VL IL cos pi, right? So VL IL cos of phi minus 30 degrees. This is the power of the first transformer. And the power of the second transformer is VL IL cos of 30 plus 30 degrees, phi plus 30 degrees. This is the power of the second transformer. Here one transformer operates at 30 degrees lagging and other transformer operates at 30 degrees leading. This is simply about the open delta connection. What is open delta? In three single unit bank, if any one transformer damaged, then remaining two units operates as a open delta configuration which delivers the power to the load but with reduced power. How much it is? Only 57.7% of delta. Only 57.7% of load it delivers. This is simply what is open delta configuration. Are you okay? Understood? Thank you very much. And this is about open delta, very important for us. Thank you.